Problem 2.7.6. Initially, 100 milligrams of radioactive substance was present. After 6 hours, the mass had decreased by 3%. If the rate of decay is proportional to amount of substance present at time t, find the amount remaining after 24 hours. So this type of problem is so wordy, you need to kind of summarize what are the given conditions. So radioactive substance, initially 100, initial value of R of 0 equals 100 milligrams. After 6 hours, so R of 6, the mass decrease by 3%. So that is 100 milligram as original times 0.97. Okay, only 97% available. So that is 97 milligram. That's the second condition. And if the rate of decay is proportional to the amount of substance present at time, so same rate, then what's going to happen at R24? That's the question. And we say this is the linear model. So we're going to use dr over dt equals kr. Then from here, dr over dt minus kr equals to 0. Now we have an integrating factor. This is a linear, so we can use integrating factor. That is e to the integral negative k dt. So that is e to the negative kt. So now we need to multiply this integrating factor to both sides or everywhere. dr over dt times e to the negative kt minus k times r times e to the negative t equals to 0. And then left-hand side, it's going to be d over dt r times e to the negative kt equals to 0. R times e to the negative kt equals c. Then R equals c times e to the kt. From here, I'm going to say R of t equals R sub 0, which is c, the initial condition, and e k t. We have R0 equals 100 milligram. So when you plug in 0 for t, R0, which is 100 milligram, equals R0 e to the k times 0. From here, R0 equals 100 milligram. Now we have R of t equals 100 times e to the kt. So now we need to find the value of k. How? We are going to use R6 equals to 97. R6 equals 97 equals 100 e to the k times 6. 7 over 100 equals to e to the 6k. Now you take the ln for both sides. So ln 97 over 100 equals to 6k. And from here, k equals negative 0.005. So finally, we can plug it in 24, find this. So we plug it in 100 e to the negative 0.005 times 24, and that is 88.53, and the unit is milligram. So we just did problem 2.7.6, and then problem 2.7.7. Let's just continue from problem 2.7.6. Determine the half-life of radioactive substance described in problem 2.7.6. So initially, that substance starting with 100 milligram, and 24 hours later, it is now 88.53 milligram. What we want to know is the t, the time when we have the total substance is going to be half, which is 50 now. So from previous example, we have this equation. All of t is going to be 50 and then 0.005 t. Find the t. So that's it. So 1 over 2 equals e negative 0.005 t, and you take the ln 0.5 equals negative 0.005 t, and then from here t equals about 138.6 hours.